We have covered so far displacement and speed, but now we are going to study regarding speed and velocity. Speed in general represented by the letter V. That's rate of change in length of path, or you might say it is equal to the total distance upon total time. Total distance, you might write here, total time. This would be known as average speed. And when you say average speed, here we consider some time interval, some size of time. Similarly, the distance traveled in that particular time. This is known as average speed. Average speed means you are considering a particular interval of time. Now, in certain motion, if the distance being covered in every successive seconds are equal, means in every second the body covers equal distance, then we would say the speed is uniform. Uniform speed is equal distances are covered in equal time. If it is not happening, which means the body covers unequal distances in the same time interval. For example, you consider 1 second, 1 second, every successive 1 second we are considering, and the body here covers 3 meters, then 5 meters, then 6. Every second it goes on changing the distance covered. Then we would say it is non-uniform speed. So you have known three terms so far. One is what is speed? Speed is distance upon time. Its unit will be meter per second. Then we got to know what is uniform speed, what is non-uniform speed, and now is the term instantaneous speed. Velocity will come to in the next discussion. Now we are going to know what is instantaneous speed. This will also be denoted by letter V. But instantaneous means a particular time. When we want to know the value of speed at a particular time, then we would say this is instantaneous speed. Instantaneous speed. Now the time interval that we are choosing here has reduced to a very small value. Then this formula, this was for a given time interval. But since we have put the condition that it will be for a very small time interval, then we'll take the limit. This will be the limit. Delta t tending to 0. This is delta L upon delta t. That becomes dL upon dt, you might say. So this is instantaneous speed, which is giving you the value at a particular instant of time. Now we'll consider one example in which we'll notice that in every second the body changes the speed. For example, it covers the distance d1 in time t1, d2 in time t2, and so on. Speeds are here V1, V2. You want to find the average speed for the given set of information. What will you do? You want to find the total distance. I'll consider only 2 upon total time, T1 plus T2. This becomes the average speed. Average speed. If you want to change this D1, D2, you can write as B1, T1 in place of D1. Similarly, if you want to change T1, you can write D1 upon V1. So same formula might be written in three forms as it's given here. You see, it has written in three styles. and all are basically same, all are representing average speed.